how to do an engineering design project. We have asked the questions, we have clarified our goals, we are very clear about what the goals are seeking, and now it's time to move on to the next steps. Hey, this is Moni Singh, an engineer, a creator, a mother, and a lifelong learner. Many people know me as Miss STEM, the founder of the STEM for Kids movement. I created this channel to help you raise your children, your students, for success in this ever transforming world laced with increasing digital influence. You watch these videos because you know that there's something more inside your kids. They got the Elon Musk type of talent hidden inside them. If you haven't done so, hit the subscribe button, and I share regularly. And as a subscriber, you have access to the practical tips, tools, and resources to raise resilient creators. All right, let's start by looking at the whiteboard. And so we have gone through, we have looked at the goal, the Engineering Design Challenge goal was provided to us courtesy STEM for Kids. And again, remember, if you have an interest in taking STEM programs and offering them in your community, serving the children, any part of the world, feel free to reach out to STEM for Kids, and I'll put the link in the description below. Now, in the last video, we asked the questions, right? So you give the opportunity to the kids to ask as many questions, clarifying questions they have about the goal, about what they're supposed to do, the constraints, the criteria, and the test setup that you have for the project. Now, once they have all the clarifying questions that they need, the children move on to the imagine step. Now, this is a time where they are thinking through multiple solutions, possible solutions for this project, and I call this the brainstorming phase. So if you set this up as a group activity, you let the children talk it out among themselves about what are the possible solutions, and also discuss things like the materials, right? So, for example, in the project we have been discussing. Okay, so they have a cardstock, they get a straw and a skewer along with all the cutting material and the sticky material. So this is a time that you can encourage the children to start thinking about the materials. And during this time, you can also allow the kids to look at the materials, maybe even touch and feel them, because sometimes touching and feeling the materials can give them some idea about the properties of that material and how possibly they can use that material in their designs. So, so you could allow that. You could actually have like a setup with at least some sample materials that they can, children can go up and look at it and at least feel it, right? And I always remind all the adults who are actually conducting these kinds of programs, is to think of yourself as a coach. And what does that really mean is that you are there to guide the children's thinking, but not necessarily to provide answers or solutions. Okay. So this is the time in these engineering design challenges, your role is to guide them, to encourage them to think about different aspects of the project. If they're missing something, allow them to think in those directions, but do not get yourself in the mix in trying to work out a solution, because you want the children to struggle a little bit. That creative struggle is an imperative for children to learn about how to persist and persevere in some of these circumstances, and be able to develop that muscle, that creative muscle, to be able to think about new ideas and new solutions. What you can do is to guide them. So let me give you an example of that. So for example, as you encourage them to think about the materials, and you'll say, okay, as you're starting to imagine possible solutions, why don't you give some thoughts to all the materials that have been provided? As a matter of fact, you could actually have some worksheets that really structures them and actually encourage them to think about these. You could have them list out all the materials, and then you can say, okay, think about the properties of this material. So, for example, you've been given a cardstock. Now, what is the property of this? It's a flat, it's a sheet of paper, it's a little bit thick. And how can you possibly use that in your design? The other property of this cardstock is that you can fold it, you can cut it, you can make it smaller. So there are lots of these kind of flexibility around this. And how could you possibly use that in your design? Now, have children think about what are the main components when you think about a car. What are the main components? Now, they may not know the names, the actual names of the different components, but at least have them think about and visualize. Right, there is a body of the car, uh, or the chassis, right? So there's a body of the car, and then the car has some wheels. And basically, that's the basic frame of the car, right? Now, children get very creative in terms of how to think about the body of the car. Some people think in terms of making a full box, some people just make a flat kind of just a base. Um, so kids can go creative whichever way they want to, but have them think about, so what material could be used to make that body of the car? And more than likely, that cardstock is what the kids will be using to make the body. However, as I described to you, there have been some very creative kids who have actually used more tape and now even the circular template. So the circular template actually is another like a cardstock, but it has circles printed on them. So that basically was meant to make the wheels, so they can cut out the wheels. And we had children who actually even used the left out pieces of paper from that circular template and used that to decorate and design their chassis. So again, kids can get very creative with all this, and that's fair game. That all is fair game. So then the next material is the straw. So you can have them think about, again, the properties of the straw. It's made up of plastic. It can bend, it can twist. And so then you ask them to think about, okay, how can you use the straw in your design? Now, one other tip here is that if you're working with really little children, so I'm talking about the 6 to 7 year old, that age group of kids, then you can do this kind of material discussion as a classroom activity, right? So you could actually have write out, make the table on the whiteboard, and you can say, okay, you are given a cardstock, and let children respond to you. You ask them questions, okay, so what are the materials of the cardstock? And the kids can respond back to you, right? They can raise their hands or they can shout out, whichever way you want to conduct that class. So you can work it that as a full class. With older kids, you can actually have them do it as their own team activity. Now the straw, and then you have the skewer, which is like a wooden stick, right, which has a pointed end. So you have a skewer also, and again, have them think about what could they possibly use the skewer for. It is made up of wood, and you can break it, but it will actually have rough edges once you break it. And in terms of the usage, and that's interesting. So just to give you an idea, and again, children will come up with different designs. We've also seen children use the straw. They cut out the straw and they use the little piece of straw as decoration material on their car. And again, that's fair game. Um, the straw has been given there to actually use as an axle together with the skewer. So you can use it to kind of position the skewer as the axle basically, but the straw allows you to stick it on the piece of paper. Many children have also been able to use without the straw. You're just sticking the skewer to the piece of paper to attach the wheels. But again, if you have the skewer, which is where you're attaching the wheels, and if you stick that to the piece of paper, the skewer doesn't rotate freely. So the axle is not rotating freely, which can create problems with their car design, and you'll find that later. And it's all okay. Remember, it's a creative struggle. So children are making mistakes, and you notice them because once you go through this activity couple of times, you will know what works, what doesn't work. And many times you'll actually feel like if a group of children is about to make a mistake, to go and tell them, hey, don't do that. That's not going to work. But please, 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 um, I really, I implore you, please do not do that, because you take away the learning from that process. The whole process is that the children are doing things on their own. They are allowed to fail, and failing is actually fine. Let them fail, but don't go and stop them. And as long as they're being safe, right? So that's the most important thing. As long as they're being safe, don't try to stop them from making failures, because once they fail, they've made something that did not work. That's when now they can start thinking about, okay, what are some other ways that they can do it so that it succeeds. And that's a big learning in itself. And I would like to encourage you to watch some of the other videos I've done around that. Before you get into this, any engineering design challenge, make sure you um, set the expectations with the children that there will be hurdles, there will be obstacles, there will be failures. They are going to feel like they're not making progress, they're stuck, things are not working, and all of that is normal. So you'll have to make sure that you set that expectation up front. And then number two, is the when those failures do happen, celebrate them, right? Because finding a way in which um, something doesn't work is also a success. Okay, so I have another video on that one that you can check out as well. Back to our engineering design project. So we were on the imagine phase, and we kind of went a little bit forward too on that one. But imagine is where they're imagining solutions, they brainstorm, they have a lot of ideas, they now have a good understanding of all the different materials, they have a sense of, they're at least getting some ideas about how they could possibly use those materials. Different kinds of ideas coming, and they could start, if they're working in teams, they can start to so in the first phase, when you imagine solution, I call it's a process of just dumping, right? Put the ideas, keep the ideas out there. You're not editing yet. Once you have done that brainstorming, then you come back as a team, or if you were doing it by yourself, then you come back and you start editing. This is a time of subtraction. You say, oh no, this one doesn't really work, let me take this one out. And then you can also try to coalesce. Maybe there are two or three ideas that can combine together to make one better idea. So that's the process you go through. In the end, you come up with at least one solution that as a team you agree on, or as an individual you feel like this might be the way to go. Hey, now that you have watched this or heard what I just shared, go ahead and subscribe to the channel if you haven't done that yet. And also, depending on which platform you're on, go ahead and give me a 5-star rating or like and comment. And also share this resource with your friends and relatives so that they can also get their hands on all this valuable information that I'm sharing. Now, one more thing, I am giving away my 7 C's blueprint for raising successful children. So if you have not gotten a copy yet, go ahead and do that right away. You can go to www.raisingresilientcreators.com. The link is down in the description. So go ahead, click on it and get that resource. It's a very valuable resource that can help you with your priority of getting your children on the pathway towards success. So with that, again, subscribe to the channel and go ahead and get that resource right away.